Now, having carried out quality benchmarking of fuels, high sulfur heavy fuel, distillate fuel, and the VLSFO fuels, we thought it would be appropriate to also look at the quality of the lube oils used in a marine engine system. It can be divided into two groups, the hydraulic system and the engine oil system. So first, if you take the engine oil system, we have worked out or computed a similar computation based on the iron content, nickel content, sodium, vanadium, calcium, phosphorus, zinc, magnesium. Very importantly, viscosity, flash point, water, and TBN. And IR sulfates, IR soot, and IR oxidation. Of these, as you well know, viscosity, flash point, water, and TBN are critical parameters, and they carry maximum weightage factor. We have seen that the normal range can be, for a new or just freshly introduced oil, can be 60 or even up to 80. However, as the oil is used progressively, we find in the case of engine oil the critical conditions where you may have to either renew or replenish the oil. The lube oil quality index is less than or equal to 30. The caution range is between 30 and 60, and if the number is greater than 60, it's normal and you can continue to use the lube oil. So when a lube oil analysis gives a number less than 30, you should immediately look for potential problems, critical problems which are important for the engine, and without going through 27 parameters of the lube oil, just looking at this number, it makes it easy for you to make that assessment. We now go to the hydraulic oil. Hydraulic oil is used in several systems on the ships, and their viscosity also varies from system to system. And a similar computation has been carried out for quality index. A critical range again here is less than 30. Caution range is 30 to 55. Normal range is greater than 55. Now the software that we are using to benchmark this is quite sophisticated. First of all, when we receive a lube oil sample, we will first separate it based on whether it's a hydraulic oil or an engine oil. Then if you take a hydraulic oil, what are the pieces of machinery where this oil is used? Is it valves? Is it pistons? Is it gear pumps? Is it servo valves? Because for each functional property, the particle count which shows where in the system, which is picked up by the hydraulic oil, the ratio varies. Particle count is expressed in 4 microns, 6 microns, and 14 microns. So that number will be different. So the comment of whether it is average or critical or normal will be based on the particle count for the respective piece of machinery where it is used. And a typical particle count reading, ISO reading, can be 17, 15, 12. And keeping in mind 17 is 4 microns and 15 is 6 microns and 12 is 14 microns. If you really look at the cube root of 4, it will be 4 into 4 into 4, 64. The cube root of 14 is 14 into 14 into 14, so that is about 2800. So you are looking at, if one 14 micron piece splits, it will break into 2800 divided by 60. That's something like 50 pieces of the 4 micron, very, very roughly calculating. So we don't worry too much about the low micron fuels, and their damage potential is also less because it will slip through the gap between the surfaces. But the damage potential of the bigger sized particles is much higher. So, taking all this into consideration, our reports will offer comments which are reviewed by qualified and experienced marine engineers who know the equipment and will provide sufficient guidance for you to set the system right and take action to prevent major damage. Thank you.